Okay, hello guys. Welcome to this training. This training is going to be a quick training. In this training, I'm going to talk about a comparison between the ICMP and then the ICMP version 6 protocol. Um, it is said that in ICMP version 6 protocol, there were certain features in the version 4 which were used in version 6, but in version 4 they were not really utilized. One of them has to do with the router solicitation and then the router advertisements. And in this video, we'll be capturing this router solicitation and router advertisement in ICMP version 6 and then seeing their key functions. The other one also had to do with this one, the neighbor discovery, neighbor solicitation, and neighbor discovery protocol. And these are key to when it comes to IPv6 neighbor discovery protocol. Okay, which I expect that most of you have seen it, but we're going to have a practical session of how to get this information, then be able to analyze it out. So generally that is that. So the essential packets for ICMP version 6 neighbor discovery protocols are here. We have the router solicitation message where a node that is wanting to find its IPv6 address engaging, for example, SLAAC. And we do know that in SLAAC has the A bit. The A bit is always set to 1. If you are doing SLAAC with stateless, that means that the router, the SLAAC, provides you an IPv6 prefix, but then also asks you to refer to, let's say, an external DNS server for certain information like your domain name or your DNS information that has the O bits set to 1 for that. And where you are not doing stateless, you are doing stateful DHCP where there is no SLAAC. It fully refers you to a DHCP version 6 server. That's where you have your M bits or set to 1. These are just an idea that I just give to you. So let's come back here, referring basically to SLAAC. So in the SLAAC solution, we have the router solicitation message, which has an ICMP type of 133. So if we have a Wireshark capture, and we can filter by 133 and then look at the router solicitation, and that is where the host is sending information to request the router to generate a prefix, an IPv6 prefix for it. It's similar like the DHCP request in IPv4. Then the router or the router has the SLAAC will reply, and that is this ID 134 will reply with the prefix and other information like the MTU or certain important information that the node require in order to configure its IPv6 address. Then there is also a neighbor solicitation, which more of talk about the duplicate address detection feature. Okay, that's one of the key functions of the neighbor solicitation. The neighbor solicitation is like a reverse app where the node says that, hey, this is an IP that I have. Is anybody on the network who has the same IP? And we find out that somebody on the network responds that with a neighbor advertisement that, hey, that IP belongs to me, then it's going to deny or it's going to stop using that IP and then generate a new IP address, either using the MAC address to generate, or we also know about the EUI 64 for local IPv6 generation, local address generation. Yeah. Okay. So we have neighbor solicitation to inform, then we have neighbor advertisement as a reply to the solicitation. Okay, and these messages are used in reverse order. The client can send a neighbor solicitation message and get the server or the router to respond to a neighbor advertisement. And it can also be vice versa. The router could also send a neighbor solicitation looking for what is the MAC address associated with a certain IPv6 IPv6 address that it has received, so that it can now begin to send information to it, and then get a neighbor advertisement from the client. So this side looks a little bit fishy, but just understand that either the client or the server can initiate any of them. Then there is also another important message when it comes to the exchanging of these NDP information, neighbor discovery informations, and that has to do with the we will see that that is the multicast listener information, or the listener reports messages, right? Yes, messages. Some you have there's the version 2, the RFC that talk about it, and this multicast listener information, which also goes alongside this, are used to negotiate what type of multicast that the the client, let me use a client, or the sender wants to negotiate on communicating. So there are a number of multicast messages that will be forming. For example, if the client wants to have a connection with the server using the OSPF version 3 multicast address, I think that is FF02 colon 12 or something like that. Let's look at the full multicast information. So at all times, the client and server needs to negotiate on what is the type of multicasting that they want to do in order to exchange certain information. So for example, if the router wants to do router solicitation, the destination address is a multicast address, and before he sends a router solicitation, he needs to establish a multicast listener with the server to agree on what type of multicast address that they want to use for the communication. I hope that makes clear. So I have a list of some multicast address to help you see. So if you see a destination is an FF021, it's just telling that it is looking for, or is sending the information to all nodes on the link local address scope. So router will use this one to send information to its link local address, okay, on the LAN. You know that link local address are not routable, they are just on the LAN. And then a client could also use the FF02 colon 2 to send information to all routers on the link local address, and that goes to all nodes. So this router sending, and then client sending to all routers. Then okay, I got that one wrong. So in terms of OSPF version 3, if you have the 5, then you know that this is information going to all the OSPF version 3 for SPF calculation, shortest path first calculations, and that, and then these are also for the DR routers. So at all times, you realize that the client and then the server are always negotiating on what type of communication they want to do. You will find most of the time that between two clients, they'll be negotiating on this one as well. Let me pull a Wireshark to explain what I mean by this. So if you check this Wireshark capture that I have over here, you realize that in the midst of we seeing the neighbor solicitation, router advertisement, there are a number of multicast listening information. So telling us that, for example, in here it's telling both the router and the client to negotiate on FF02 colon 16. That is multicast listening versions 2 for hosts that need to participate in a multicast traffic. Use this group to discover the multicast router. So you'll find there will be a number of exchanging. So this, for example, is FF02 colon 1, if I'm not mistake. Okay, that's just that. So this is let me just make it a little bit bigger here. Okay, another multicast address 16. Here is all 16. Let me see if I have more multicast addresses. A little bit slow, but the multicast addresses tend to change as the traffic gets negotiated. So do I have any new ones? Okay, I think over the top here. Okay, so multicast addresses basically depend on what it goes for, that goes in for it. So let us start with our capture and then let's analyze what comes through. So here I am. This is the network topology I have. So I have a various router, open source router, and then it's doing SLAAC, giving a DHCP pool to this node over here, and we'll be capturing the packet and be analyzing the ICMP packets that helps it to acquire its IPv6 address. So I could also log into the router and then show what it captures. So I have logged into BIOS 3, and then what I'll just do is let me get this let me just get through with a command here. So we are in the RAM mode, so you can talk about run monitor traffic, if I'm not mistaken, yes, traffic, and then on an interface monitor traffic interface. Okay, so what type of interface? The port is on ETH2, so I can also capture here instead of using Wireshark interface 2. Then I can decide to introduce a filter, and in my filter, I can look specifically for the ICMP types that I'm looking for here. So I can have something like this. Okay. Dot type, and I want to introduce the various types that I have. So IP6 maximum, the IPv6 header is 40 bytes, so I can just introduce that. I should just capture like that, and then sorry, let me just clear all these things off. So it's a very long it's syntax. We have it right. So let me just use this part if I just have it right here. So what I'm just doing is I'm going to run the traffic, monitor the interface, and what I want ICMP version 6, and then I'm introducing the types. So the types is what I put here: 133, 134, 135, 136, 137. I also capture the multicast address, so that is found here. So you see I'm introducing the types here: 133 for the router solicitation, 134 for router advertisements, and then neighbor solicitation, neighbor advertisement, and then 143 is for the multicast listening reports. Okay, so once I have it like this, we can go ahead and then run this capture. So we can just go ahead and then run the capture. Okay. Okay. So it says that currently it's listening, and then it's ready to capture packets on the interface. So listening TCP dump, listening to this port, and then it's ready to capture packets on this interface. Okay. So currently it's seeing some packets coming, but I'll reboot it so that we can get all the information that we require. So we'll come right here, I'll stop it, and then I'll start it up again. Then let's go back for our packet capture. Then let's see what we're getting now. Router advertisement is something that the node will always advertise. For example, in Cisco, every 200 seconds, there's a router advertisement which is trying to advertise its link local address and then going to the multicast address that we talked about, the OFs. Okay, so here we are. So we started key informations that we have here. As soon as the node came on, it has its link local address, and then it sourced it from the unsolicited node. I remember you can configure this on any node at all, but it has its link local address, and then it sends a neighbor solicitation, that is a DAD, asking that, hey, is there anybody on the link that has my link local address? So it's sent to the multicast address, has my link local address. As soon as it doesn't get any response, so there's no duplicate address detection, the client goes ahead and then uses that address over here and then sends a router solicitation message to the OF02. So this was what I'm talking about, that the multicast address will keep changing and they will negotiate based on what they are looking for. So sends that information, router solicitation, asking for information that will help him to configure its global IPv6 address. So that information gets to the router. The router uses its link local address to respond to the link local address of the client. Same thing over here. And in this information has the router advertisement information. The router advertisement information will generally contain a prefix. If we do come over here, I can get one router advertisement information. So there you go. So it do contain a prefix, and we expect the client to use the EUI 64 prescribed with its MAC address to generate the interface ID part of it. Of course, if the client generates that interface ID section of it, it will definitely has to do a neighbor solicitation to ensure that that IP is not used by anybody. So let's go back. Okay, back to our capture. All right, so it sends, so the client, the server or the router gives the advertisement message, and as soon as it gets it, now you can see that here the client, the server is making a solicitation for who has this. So that means that the client has configured this. Did I miss the capture? There must be a capture where the client solicits for this IP. Let's look for the let's look out for the MAC address for the client. I expect that should be here. Yes. So over here, if we come right here, after the client giving this, yes, this is what I'm looking for. So you realize that the client's MAC address is saying the client is using its MAC address using the all solicitor and then doing neighbor solicitation, that's the DAD, asking that, hey, is there anybody on the network who has this IP address? If he doesn't get any response, then he'll be good to use this pending the approval of the router. So the router also comes in. If you look at display, you can see that the source has now changed to the link local address of the router. The router also comes in and does a neighbor solicitation for the IP address that he saw on the network. And then when it gets that, we expect the client who owns the IP address to respond, and that is the neighbor advertisement. So the client responds back to the server that that is my IP address, and based on that, they can still keep on negotiating on multicasting, and then being able to keep on neighbor solicitation keeps happening a couple of times, but once they've negotiated, they can now send the traffic. I hope this has been very informative. I've tried to keep it very short, and I hope it's very clear to everybody. It's still the same kind of thing that is happening right here. If there are any questions, just reach out to me, as I love to share. Thank you and have a great time.